Hello and welcome. I'm your Geek Eric, and today we're going to answer a few questions about object pools. Like, what are they? And why should you use them? Would it benefit your game? And if the answer to that is yes, then how would you go about implementing it in your project? Let's jump on into it. So, what is an object pool? Well, the system is actually pretty simple. I'm going to write out two different areas. We're going to have a square over here representing the object pool. And over here, we're going to have a class that wants to spawn in some objects. So we'll call this a wave spawner. I'll just put an S for now. So the wave spawner is going to want to do a few things. It's going to want to ask for an object from the object pool, and it's going to want that object to be returned to it. So let's say the wave spawner calls a function called take object. Well, that function will be called in the object pool, and if the object does not exist, then we may need to load the object into the pool. Now, after we load those objects, we need to return an object back to the wave spawner. And so far, you may be asking, well, how is this benefiting my game? Well, now let's get into the why. So, this first part by itself wouldn't benefit your game. But let's say that you're spawning in with your wave spawner a pickup. Well, whenever the pickup gets picked up, or maybe it goes off screen and you want to get rid of it, well, the pickup can call a return function. Let's say return object, and we can return the object back to the pool. And so the next time that the wave spawner goes to spawn another pickup, instead of creating that object, well, the object already exists in the pool, so we don't have to load the object again. And this does a few things. It keeps us from having to load the object, but whenever you delete objects, and load them for that matter, there's some memory management that is being done under the hood. And if you load or unload enough objects at a time, it can actually cause your game to have like a stutter. You may have seen this whenever you're going from one area of a game to another. It's loading in a big chunk. And basically, there's a lot of games that can take advantage of this system. A bullet hell game. So let me make a new image here. So a bullet hell game, you could be shooting a bullet, and whenever it gets off the screen, you can just return the bullet back to the object pool. Or when it hits something, you can return it back to the object pool. And that way, you could seemingly have an infinite number of bullets and not increase your memory usage and not incur those memory management slowdowns that I referred to earlier. So if this sounds like it would be beneficial for your game, let's jump on to the next segment. I have a project already made on GitHub that we could go ahead and download, and all we need to do is walk through adding in the object pool to the project. Before we move on, if this video has helped you so far, maybe you enjoy game dev content like game jams or project devlogs, and you may need some more tutorials in the future. Hey, I don't know. All I know is that it would help me out if you would subscribe and like this video. Thanks. Now let's get back onto it. So all we need to do is go to my Git repo. It's going to be linked in the description box down below next to my Instagram and Twitter, might I add. You could check those out too. We're just going to need to click on this green button here, code. You could just click this download zip button here. Either works. So we're just going to extract it, and I'm going to open it up in my file manager. Let's just double click on the project file. And now that we have it opened, let's go into the scripts and helper and open up the object pool. Now we could just delete this comment here. I'm just going to save it and quickly walk you through the project. So it's a really simple setup. You have a root world node. You have a lucky sack, which is just a script that holds your score. We have a wave spawner that takes an array which grabs the objects from this array over here. So let's say you had multiple objects in this array. It would grab just the first object. You could come in here and you could change this to a 1 and it would grab the second object. We're just going to leave this at all zeros. And what this is currently spawning, this $100 pickup prefab. And that pickup is over here under prefabs, pickups, $100. And we could see that it's just a little $100 with a collider on it. And whenever you collide with it, if it's the player that's colliding, we're going to add some points. And then we're going to clean up and return the object back to the object pool. And that cleanup function is in the parent. So the cleanup function just calls the object pool return node and passes it itself. Oh, one more thing. The object pool in this project is a singleton, which is located here in the auto loads right here. So what that means is that no matter what scene you're in, the object pool will exist. In some games, you may not want that. For the project that this was made for, it was actually better for it to be a singleton. So that's what I went with. So first, we're going to need a few variables. We're going to need a minimum amount of objects to load. I currently have it set to 10. We are going to need a dictionary to hold the objects that we currently have loaded. This dictionary is going to have the key, which is going to be the name of the object, and then the value of it is going to be all the objects that are currently in the object pool. And then over here we have this return queue, and I'll get into that later. So the first function we're going to add is the take node function. Now, if you're having trouble typing it this fast, just pause the video, type it out, and then come back for the explanation. So I have a little comment here giving a short explanation of the function, but let's walk through it line by line. So the path is just the file path, nothing special. So we're going to make a new variable object that's just going to exist inside of this function. We're going to check to see if the path is not already in the object pool. And if it's not in the object pool, we're going to do another function. We're going to load that object. We'll get that in a second. If it is in the object pool, we're just going to take out one of the objects from the pool with the same path as it. And we're going to, after we take that object out, we're going to erase the path. We're going to erase the object in the array. And now if there's no more of that type of object in the pool, we're going to erase that whole object key from the dictionary. So nothing too complex. We're going to return the object that we grabbed out from the object pool. So next, let's go through loading the object. So loading the object, also pretty simple. All we're going to do is pass the path from the takeNode function to the load object function. We're going to load the resource, and we're going to hold that reference to the resource. And for as many times as you specified up at the top, we're going to make a new instance of that object, and we're going to store it into the object pool. Now, the only reason to have the difference here is because if the object pool is already populated, all we need to do is append it. And append is just adding a new element to the array at the end of the array. If the object does not exist in the pool already, set a new key in the dictionary, and that key is going to be the path. And then we're going to set one object into the array. So we've already covered loading in the objects. Now we need to cover putting the object back in the pool. And this is actually what caused the most problems for me. Along with memory management, another good use of an object pool is that while the object's not in use, well, we don't need to execute any of the scripts inside the object. In Godot, to stop execution, you need to remove the object from the tree. There's one catch. If you try to remove an object from the tree, and the tree is just this hierarchy of objects over here. If you try to remove an object from the tree while collision is happening, it throws a lot of errors. Now, it doesn't necessarily crash the game, although sometimes it does. Anyway, the best thing we could do is just not remove the object while collision is happening. So that's one of the big use cases. Whenever it hits a wall or an enemy, we want to put it back in the pool. So the workaround that I did for this is making this return object queue. If the object already exists in the queue, let's say that you're calling it really fast and it still exists in that queue, then we don't want to add it back into the queue again, having a duplicate. So let's just return. But if it doesn't exist in the queue, then we're going to add it to the queue. And a good way to not try to remove it from the queue during collision is to in the process, we're going to clean that return queue. So the last function of this object pool is to clean the return queue while the return queue is greater than 0. So just to walk you through this part, while the return queue's length is not 0, we're going to pop the front object in the array. And what that does is it says, hey, who's the front object? Raise its hand. You pick it up, you take it out of that array, and it returns it. And you could then store it into a local variable inside the function. So now we have that first object no longer existing in the array. We check to see if the object's null. This is just some error handling. Potentially a null object can get in there and cause problems, but we're just going to say, hey, if it's a null object, return. Don't worry about it. Then we get the parent of the object. Again, if the parent's null, this is more error handling than we return. If the parent's not null, then we remove the object from being a child of the parent. And what that does is it stops the execution of future collision, any scripts you have on that object. It stops the execution of those scripts. That way you save on some of those CPU resources. It also takes it out of visual space, and so you're saving on some GPU resources as well. So after we've removed the object from the tree, we're going to check to see if our object pool contains a key for the object. If it does, we append it to that list, and if it doesn't, well, we just make a new entry in our dictionary and we add the object to it. So let's check this out. Let's see if it works. So I'm just going to pull up the debugger over here. We're going to track the objects. And as you can see, we can pick up some pickups. It's just spawning in more and more waves. The nice thing about this script is as you need more objects, like for example, if I may not be able to do this again, but if I need more of these pickups on the screen, well, it just adds more objects to the object pool. So, you can see this is a pretty flat graph. Again, this is whenever we need more objects on the screen. It bumped it up. This is a pretty flat graph. Let me demonstrate to you what happens if we were using a more conventional system where when the pickup's picked up, it gets deleted. Or when it goes off screen, it gets deleted. So to demonstrate that, we just go into the pickup, and instead of that nice cleanup function, we do queue_free. And what queue_free does is after collision, it removes it from the tree and deletes the object. Let's do queue_free there. So that's whenever it gets picked up. What about the off-screen part? Let's see. Okay, so on-screen exit, we're also going to take that out and put queue_free. I could have just put that in the cleanup function. Let's check out that graph again. So let's hit play and go to monitor, show the objects. Then we could get over here, and if we start collecting a bunch of objects, this game's simple enough that you're not going to see the slowdown in its current form. But potentially, if you expanded this game and it was running on, maybe like an older phone or something, you would be seeing some slowdowns in these parts of the graph where it's deleting and having to create more objects. And really that's just wasted performance that you could be using on something else. Like, let's say that you're not trying to run it on old hardware, but you're trying to squeeze as much performance out of the computer that you are using it on. And this is, if you're not using an object pool in this case, you're leaving performance on the table. So I hope this video was useful. Again, if it was, hey, that subscribe button's there. There's a little bell next to it. You give it a little ring. If you have any suggestions on how I should do tutorials in the future, please drop them in the comments section down below. If you have any experiences of how an object pool helped your game, or a project that you're working on that you're going to add it to, drop those in the comment section. And I'll respond, and we'll have a good conversation down there. Thanks for watching. Catch you guys next time. Bye.